record. Okay, guys, so we're going to talk about continuity today. And a function is continuous at some point, x equals c, so maybe x equals 5, as long as all of these things are true. You have to have the limit as x approaches that point, and that's got to be a two-sided limit. First of all, it has to exist. It means the value at that point has to exist, and they have to be the same. If all those conditions are met, then that means you have continuity at that point. Now, continuity sounds a lot like the word continuous. Agreed? So basically, what we're trying to determine is, will this graph have a hole? Would it have an asymptote? Would it have an open circle and then maybe have a closed circle at a different value for that point? Because if any of those things happen, it's not continuous. So as long as it is continuous, this is sort of the test. So if we're looking at a graph, it's pretty easy to see. If all we had were equations, this is how we can figure out if we've got continuity at that point or not. So look at this. We've got some properties for continuity. If you get a constant function, something like f of x equals 4 or y equals 7, tell me what that graph would look like if you were to graph it. What does y equals 7 look like? Horizontal line. If it's a horizontal line, wouldn't that mean it's got to be continuous everywhere? Absolutely. So that's going to be continuous. As long as you have x raised to a power and that exponent is a positive integer, so like x squared, x to the 5th, x to the 7th, then that means your graph will be continuous for all values of x. If you have a polynomial, remember what polynomials look like, right? Something like 3x cubed minus 2x squared plus 5. It's not going to be a fraction. It's just going to be something that has, it can have several terms. It could just be one term, but there's no fractions involved. There's no variables that would be under a radical. That would be a different kind of function. No absolute value bars involved. As long as it's polynomial, it's going to be continuous. A rational function, that means it's a what? Looks like if it's rational, it's a fraction. Very good. So if we have a fraction that's a function, it's continuous everywhere except for values that would make the denominator what? Exactly. That means there's either a hole or an asymptote there. So a lot of this you already knew. Now here's one that we haven't looked at a lot. The radicals, if our function is something that is a radical expression, look at your index. As long as your index is an odd number, like a cube root or a 5th root, and it's positive, then that thing will be continuous everywhere, okay? But what's the problem if it's even? Like a square root. Can I put any kind of number underneath a radical if it's a square root and get a real number back? It has to be what kind of number under the radical. It's got to be something that's 0 or greater. So as long as it is non-negative, that would be underneath the radical, 0 or a positive number, it will be continuous for all those values. Now, sometimes it may be a challenge to solve some of these to determine, especially if we see inequalities. So maybe they give us a function and they're wanting us to find all the values where the function is greater than 0, where it would end up being positive. We might have a hard time figuring that out unless we construct a sign chart. I'm going to show you how to do that in a little bit, but basically we're going to look for any values that would either cause the numerator or the denominator to become 0. Those are going to be called our partition values because that's going to be the only place where a sign could change. is either where the numerator becomes 0 or the denominator. And then we're going to run this sign test. So let's turn the page. We're going to look at some different questions related to continuity. Now, I should have just taken this off. You're not going to have to sketch a graph that matches some verbal statement. So I'm not going to make you do that. But I am going to give you some homework where you've got some functions and you're supposed to determine where the function is continuous, and then you're going to give me your answer in interval notation. Now, if it turns out to be something that when we look at it, we say, oh, I recognize this one, you know, this is constant, or this is polynomial, or whatever the case may be. You may not have any work you have to do. You just look at it and you know what it is. For example, if I were to ask you on A, f of x equals 5x squared minus 2x minus 9, what kind of function is that? It's, say it again. I think I heard quadratic, which is a type of polynomial. And what did it tell us about all polynomial functions? They're continuous everywhere, right? So if it's continuous everywhere, how would I express the interval of continuity? It would go from negative infinity to positive infinity, and we would use parentheses around that to indicate that it is continuous everywhere. Now, as I look at g of x on B, I'm noticing this thing is a radical. And if it's a radical, do I sometimes have places where I don't have continuity? Especially if I have an even index. What kind of root is this? It's a square root. That's an even index. Square root means the index is 2. So the only place it's continuous is for what values? When it's got to be non-negative. So I'm going to take what's underneath the denominator. And not the denominator, sorry, the radical, which is the 6x plus 5. And I need to know what values would make that greater than or equal to 0. Because I know I've got to have either 0 or a positive number underneath the square root. Can you solve that? By doing what? Subtract the 5, and you get 6x is greater than or equal to negative 5, and then do what? Divide by 6. Now remember, I can multiply or divide by positives when I have inequality statements. Doesn't change a thing. What's the one thing I got to be careful about? If I multiply or divide by a negative, then I have to, reverse the inequality. A greater than will become a less than, and vice versa. So this tells me as long as x is greater than or equal to negative 5/6, that this thing should be continuous. How would you express that in interval notation? Well, remember interval notation, you gotta have a starting point and an ending point. So where would it start? What's the smallest value? It's gonna start at negative 5/6 and go to positive infinity. Now tell me how to close this thing off. What goes around negative 5/6? Bracket. Good, because it's included. And then infinity gets a parentheses, right? Okay.
Okay, so you didn't switch the sign, or you did switch the sign?
Okay, your question was, did we switch the sign or did we not? And the answer is we did not, because what did we divide by, a positive or a negative? A positive. So since we divided by a positive, we did not switch the sign.
So what does it mean by looking at the index if it's even?
If it's even, it means there has to be a positive value under the radical. So you would take whatever the function is, the expression under the radical, and set it to be greater than or equal to 0 and solve for x. Okay? Now, if it had been an odd index, if this had been a cube root, is there any problem with having a negative under a cube root? Remember, cube root means what could you multiply times itself 3 times and get that back? So can I multiply any nuts? The problem with the square root is, can I multiply a number times itself and get a negative? The answer is no, because a positive times a positive gives me a positive, and a negative times a negative also gives me a positive. It's impossible to get a negative that would be under a square root and get a real number value as a solution. It just doesn't work. It doesn't fit the sign rules that we have. But think about a cube root. If I asked you, is there some number you could multiply times together 3 times and the answer would be -1, is there? Yeah, because -1 times -1 times -1 is -1. As long as it's an odd number, when I multiply a negative together an odd number of times, it still stays negative, right? And if it's a positive, doesn't matter how many times I multiply it together, it's going to stay positive. So as long as it's an odd index, I don't have any restriction. It should be from negative infinity to positive infinity. Yes, ma'am.
So if it is a regular square root of -1, we get to adjust this continuous.
So you're saying if there wasn't an x value under the radical and it just said square root of -9, that would not be a real number. And so if you were given that as a function, there is no real solution for it. But I think you're always, I don't think they're going to give you that as a constant. I think anything that they would give you as a constant will actually be a real number. Okay? But that's a good question. You guys are thinking, coming up with different scenarios. Now, look at this next one. I've got h of x equals x squared minus 16 over x minus 4, and I'm supposed to decide where this thing is continuous. Now, if it's rational, where am I going to have a problem? It's a fraction, so where would I have a problem where I'm going to have an issue with continuity? When the denominator equals 0. And will it matter if it's a whole or if it's an asymptote? Is there still discontinuity there? Yes, so I don't even have to worry about whether it's a whole or an asymptote. All I have to do is set the denominator equal to 0, and the value that's going to give me a problem is what? When x equals 4, then the function does not exist. So how do I express the interval where this thing is continuous? And I want to show it can be everywhere except it can't be when x is 4. Do you remember how to do that in interval notation? Maybe it's been a while, so let me jog your memory. Can we have the smallest number you could possibly think of as part of this, where it's continuous? Because the only place I have a problem is when x is what? 4. So I can start at negative infinity, and I can use any value until I get where? To 4. Now, do I want to close 4 with a parentheses or a bracket? Because 4 is not included, right? So I'm going to have to put a parentheses at 4 to show I want you to include everything all the way up to 4, but when you get to 4, don't count it. Do I have more values I need to include? That means I need a second interval. So I put a big U for a union sign to show there's more than one interval, and I'm going to start where? 5. Yeah, if I start at 5, it means I'm going to skip any value between 4 and 5. Do I still want to count those? So I start at where? 4. But do I want to include it? No, that's why I'm going to have to put a parentheses around the 4 and then go to positive infinity. That's how you would use interval notation to show I'm continuous everywhere except when x is 4. All right, so if it's been a while since you've done that, that's something that would have been covered in, say, college algebra. Hopefully that jogs your memory a little bit. I think we talked last time about the difference between parentheses and brackets in terms of whether something's included or not. So this is the one you got to be careful about. I want everything except 4. So since I want 4.000001, I can't skip all the way to 5. I'm going to have to start at 4 but use a parentheses. Okay, so that makes sense? Now, if we look at the next part, it says determine all points of discontinuity and discuss the behavior of the function at these points. Now, if they give me more than one equation and they give me these inequalities over here, do you remember what we call this graph if we were to look at it? It has a special name. When there's more than one piece, it's a piecewise function, okay? So it means this is going to graph for every value of x less than 2, and that thing's linear. So I know I've got a line somewhere for x values less than 2. What's this going to be the graph of? That's a quadratic equation, isn't it? X squared plus 1 is quadratic. So anytime x is greater than or equal to 2, that piece of the graph is going to be a curve because it's going to be part of a parabola. Now, here's the thing. I don't know yet if the line and the parabola join at the same point, because if they do, would it be continuous everywhere? Right, but they could also have that gap where the line stops at 2 and has an open circle, and then there's a space and some other point where x is 2 is where the parabola starts and it's got a closed circle. And in that case, I do have discontinuity. How am I going to figure out whether they join up or there's a gap there? All I got to do is plug 2 into each of these to see if I get the same y value back. Because if I do, it means the 2 pieces join up and it's continuous. If I don't, it tells me that it would be discontinuous there. Does that make sense? Okay, so that's a pretty easy test if that's all it's asking me to do with these piecewise graphs, is just to decide if I've got a discontinuity or not. So for A, we're going to find what f of 2 is. For this top equation, 3 times 2 plus 1 is how much? 7. Now, I'm going to plug it into the bottom equation, and that would be 2 squared plus 1. And that's how much? 5. Were those the same value? No. And what I know is this one is an open circle because it came from the inequality that doesn't have the or equal to sign. This one is the closed circle. That tells me I've got a gap in there because these are not the same y values. So what would you tell me? Do I have a point of discontinuity? Yes, I have a point of discontinuity at x equals what? At 2. There you go. I would have a point of discontinuity at x equals 2.
Okay, so on 2g, why did we put that greater than or equal to? Like, what determined that?
On 2g. This one?
Yes.
Okay, because this function was a square root equation, is it possible for the radical to have 0 underneath? Can you do the square root of 0? Is that legal? Yeah, because 0 times 0 is 0, right? It said it had to be a non-negative number. And 0 is not negative. It's not positive either. It has no sign. So what was under the radical just had to be greater than or equal to 0. That's why it was closed. Okay? Good question. All right, so we have decided we had a point of discontinuity on 3a at x equals 2. Okay, let's look at 3b. And on 3b, we have 2 more equations. The top one is x cubed minus 4, so it's going to have some wiggling going on. That occurs when x is less than or equal to 0. And then when x is greater than 0, we use the line 3x minus 4. So how am I going to figure out if I've got discontinuity there? Exactly, plug into both. So I want to find f of 0 when I use this top equation, and I get what value? -4. And then I'm going to find f of 0 in this bottom equation. And what do I get there? So what would you tell me about that? Do I have any points of discontinuity?
No.
No, there are no points of discontinuity, because when I plugged in 0 in both of those, I got the same value. So that basically means the closed circle will be on top of the open circle, okay? And it will be a continuous graph. Now, let me show you how the sign chart thing works. Because I'm looking at this and it says x squared minus 7x minus 18 is less than 0, okay? And I am supposed to solve this inequality. Now, how am I going to figure out when that polynomial is negative? Because that's when it would be less than 0. Not real easy to tell just by looking, wouldn't you agree? I mean, I could kind of randomly guess some values for x, but that's not very efficient, and I might not find everything. So let me make a suggestion. If you remember, on the front side, it said we want to find our partition values, which means any value that would either make this equal 0 or would make a denominator equal 0. So it's either going to be equal to 0 or equal to something that's undefined. This has no fraction. I don't have to worry about a denominator equaling 0, but I'm going to see what value or values would make x squared minus 7x minus 18 equal 0. In other words, I better check and see if this thing factors. So let's see. If I multiply the a times the c, that's what value? A negative 18. And if I'm multiplying two numbers together and I get a negative, tell me about the signs. They're different, one negative, one positive. My b value is -7. Okay, now start thinking of actual numbers. What could you multiply to get -18, add to get -7? 2 and 9. Now, which one of those needs to be the negative? The 9 is negative, the 2 is positive. That means this thing could factor as x minus 9 times x plus 2. Quick reminder, how can we make sure we got it factored right? You could use FOIL or that box to multiply it back together. We do have it factored right, okay? If I double check, I'm going to get -7x for that middle term, and the -9 times the +2 does give me -18 for the last term. Now, let's set each of the parentheses equal to 0. So if x minus 9 equals 0, x plus 2 equals 0, tell me what these partition values are, these important values where I might have something that changes, because it's only going to change signs from positive to negative or negative to positive if it passes through 0. Doesn't that make sense? I mean, if I'm going from a negative number to a positive, I'd have to go through 0 to get to the other side. So that's why these are important values. So I'm interested in when x is what? 9 or -2, because I said each one of those equal to 0. Now, these are called our partition numbers. And here's what we're going to do with them. We're going to draw a number line. And all I need on my number line will be these two values. -2 is furthest to the left, +9 is furthest to the right. And you know how we were testing at asymptotes to see if something was moving toward positive infinity or negative infinity, so we just picked a number to the left or to the right to see what was going on? That's what we're going to do with these partition numbers. I want to see if I'm to the left of -2, do I get a value that's positive or a value that's negative? And it's going to be easiest to figure out, I think, if we look at the factored form. So if we're looking at x minus 9 times x plus 2, and I want to see what happens if I pick a number to the left of -2, what would be just to the left of that? -3. So let's see what happens if we were to put -3 in there. And again, I don't care about the number. I just want to see what sign comes out. If I have -3 and I subtract 9, what sign do I have? A positive number or a negative? That's a negative. And if I have -3 and I add 2, is that positive or is that negative? A -3 plus 2 is negative, isn't it? And what is a negative times a negative equal?
Positive.
That tells me these values to the left of -2 should be positive numbers. And you could try another one and see. If I put in a -4, and on both of those, there's still going to be a negative in the first parentheses, a negative in the second, and a negative times a negative will give me a positive. So anything to the left of -2 is going to give me some positive value. Now, pick something between -2 and 9, and what would be the easiest number to plug in? I could use -1. I like 0, because yeah, it's really easy to add 0 to something. So let's see what happens if we find f of 0 in x minus 9 times x plus 2. So if I put in 0 here, 0 minus 9 is what sign? Negative. What's 0 plus 2? That's a positive. And what's a negative times a positive? That's a negative. So that tells me any number I pick between -2 and +9 is going to give me back a negative value. Now let's see what happens to the right of 9. What would you want to use? So let's try f of 10. And if I plug in 10, what's 10 minus 9? 10 minus 9 is a positive. And 10 plus 2 is a positive. And what's a positive times positive? Positive. Okay. Now when I look at my sign chart, I ought to be able to answer the question, where would I get a negative value for plugging something in for x in this function? It's in between -2 and +9. Now, do I include those values or not? No, because those values actually make it 0, right? If this had an or equal to, I would include them. Since it doesn't, I am going to express the interval where this is negative as being between -2, comma, and +9. Does that sort of make sense? It's not necessarily difficult, but there are several steps you've got to remember to do to figure this thing out. Okay, now I think I'll do this to do B. So we've got a little more room. Our function is this, x plus 5 over 4x minus 3, and we want to know when it's greater than or equal to 0. Okay, so what do you think we need to find first? We need to find those partition numbers, so we need to find what values would make either the numerator or the denominator 0, correct? Okay, so if I set the numerator equal to 0, so I'm finding my partition numbers, and that means I set x plus 5 equal to 0. I'm also going to set the denominator equal to 0. And that gives me x equals what? -5. Or on this one, if I add 3 to each side, then if 4x equals 3, what's the other value x could be? Want to be a positive? Yeah, after I move the -3 to the other side, I've got a -5 or a +3/4 are my two partition numbers, okay? So x equals -5 or +3/4. Those are my partition numbers. All right, once I know those, what am I supposed to do with them? I do what? How about draw a number line? Yeah, let's do that. Okay, so we're going to take this and we're going to draw a number line where we put -5 and a +3/4 on here. And I'm going to have to pick values that are to the left of -5, in between the two, and then to the right of 3/4, so I can pay attention to signs. Because remember, we're looking for where will this give me a positive value or 0. So if one of these points, I know both of these points actually give me 0, so I'm going to need to see if it's in between, or it might be this way. I don't know. All right, let's find out. So pick something to the left of -5. So let's see what f of -6 is. And that would mean if I were to plug -6 in for x in this original function, it would look like that. -6 plus 5 over 4 times -6 minus 3. Now, again, I'm only interested in the sign. So if I add -6 and +5, is that positive or negative? That's a negative on top over 4 times -6 is -24. If I subtract 3 from it, that's what sign? And a negative divided by a negative is a positive. So these are going to be positive to the left of -5. All right, what number between -5 and 3/4? Let's try 0. So if we put in 0, let me pull this up so we can kind of see what we're doing here. We're going to get 0 plus 5 on top over 4 times 0 minus 3 on bottom. So what sign do I have on top? Positive over a negative on bottom. And a positive divided by a negative is a negative. So in between these two, the values are always going to be negative when I plug in. All right, go to the right of 3/4. What's the next integer just to the right of 3/4? 1. And that would give me 1 plus 5 on top over 4 times 1 minus 3 on bottom. Sign on top, plus over, which is positive. Okay, now look at our sign chart. Can you tell me how many intervals do we have that are greater than or equal to 0? How many places do you see plus signs? There are 2 intervals. Remember what we did a moment ago when we had 2 intervals? We have to write them separately and put the U between them. So what would be all the values of x that would give me back a positive number when I plug into this? It would start where? -infinity and go to -5. So I'm going to actually write it on here. We would start at -infinity and we would go to -5. Now, do I want a parentheses or a bracket around the -5? That one, I need a bracket because it had the or equal to. But I also know there is another section. And where does it start? It starts at 3/4. And because of the or equal to, I want a bracket there. And it goes to where? Positive infinity. Those would be the values that would provide the solutions for that. So we really weren't finding limits on that, but we were using some of the tools to be able to evaluate these inequalities when, and that's going to help us